All right, in this question we are asked how many grams of nitrogen monoxide are produced, that's this stuff, if 4 moles of ammonia are burned in 20 moles of oxygen. Okay, let's balance things first. I'm wondering with this and this, I probably need to go to 6. Let's try. So if I put a 2 here, that'll give me 2 NO, 2 nitrogens. That gives me 6 hydrogens, so I need to put a 3 there. Oh no, that's going to give me 5 oxygens. So I'd need a 2.5 here. Let's double things. So, whoops, I should have written down what I was doubling. So I'm going to put, is it a 4 here? 4 nitrogens, 4 nitrogens, 12 hydrogens, 12 hydrogens. Now I have 6 plus 4, that's 10 oxygens, so I need a 5 there. There we go. So we have it balanced, and so they want to know how many grams of this we have. So on my river over here, this right side is nitrogen monoxide. I'm going for a solid, that's where I need to end up. And they say I have 4 moles of this stuff, and I have 20 moles of oxygen. Well, when I look at that, I got too much information, right? And when you have too much information, basically you're looking at a limiting reaction question. So to do the limiting reaction part, I need to check to see if I got too much of this or too much of this. So when I look at it, and this is the process I would do, is let's say, okay, we're looking for limiting reactant. Let's say it's ammonia, just for example. So is it ammonia? So to do that, I would figure out how many moles I have. In this question, they already gave me moles. So I'd go 4 moles of ammonia. And I'm getting this number from right there, 4 moles of ammonia. And I can use dimensional analysis. I'm just sort of doing the across the river step. I can use dimensional analysis to figure out how much oxygen I need. So what I want is 5 moles of oxygen, and I have 4 moles of ammonia. So the moles of ammonia cancel. 4 times 5 divided by 4 gives me 5 moles of oxygen. So that's how much I need in order to react with 4 moles of nitrogen. But then I ask myself, well, how much do I have? How much do I have? And I look up here and it says I've got 20 moles. So I've got 20 moles of oxygen. That's tons. So this one here will be my excess reactant. And it means that this one must be my limiting reactant. Okay? So this part here, I've already done my, well, I guess I haven't done my river part. Because this was to get me to moles of oxygen, I want to go to moles of nitrogen monoxide. Okay, so now I know that this is limiting reactant, so let's do the next part. So I'm starting here, and I need to go across the river. Because I'm starting at NH3, I know that that's my limiting reactant. I'm not starting with the oxygen. And I need to get across the river. So first step then, I'll write how many moles I have. 4 moles of ammonia, and it uses 4 moles of ammonia to produce 4 moles of nitrogen monoxide. So these cancel. So 4 times 4 divided by 4, yeah, it comes up with 4 moles of nitrogen monoxide. Okay, now I'm right there. So I have moles of nitrogen monoxide, and now I need to do, so that would have been step 1. Step 2 would be to get me from moles to a solid. So I need to go from moles of nitrogen monoxide to mass of nitrogen monoxide. And to do that, you use this formula, mass over molar mass. I'm looking for mass. So mass is equal to moles times molar mass. the moles I have are 4 times the molar mass of nitrogen monoxide. I'll do it over here. So nitrogen is 1401 and oxygen is 16. So it'd be 3001. So times by 30.01 grams per every mole of nitrogen monoxide. Those cancel. 4 times 30 gives me 120.04 grams. If we're worried about sig figs, right up here, I've got 1 sig fig, there I've got 1 sig fig, so I can only give 1 sig fig in my answer. And this one I should have given more sig figs in the question, but if I can only give 1 sig fig in the answer, it would have to be 100 grams, and no decimal place there, otherwise I'd give you sig figs. Okay, hopefully that helps you with that, especially the limiting reactant part.